Let's look at a circuit that contains only two elements. So here is the example. And we have a resistor only and in capacitor. There's only two elements here. And what we know here is that we actually know the Y for this particular circuits here, and let's call this as R and this is the C. If we know the given here, if we know the omega is 100 radians per second, and then we also know Y, that total admittance is given, that's a 0.1 plus J 0.2 and Siemens. What we want to find is we want to find R. What is the value R? What is the value C? Now let's see how we operate this. First of all, we know that if in series connection, that we know 1 over y is equal to 1 over y1 plus 1 over y2, and we can simply call y1 is the resistor, y2 is the capacitor. And this is equal to R 1 over y1 is Z, and Z for resistor is simply just R, and then plus 1 over y2. 1 over y2 is Z2, which is the impedance of capacitor, and that gave us a negative of 1 over J omega C. So this is on the right hand side. On the left hand side, 1 over y, that's actually is given. So that is 1 over 0.1 plus J 0.2. That is equal to R minus, I'm sorry, here this is the J should be on right here. And that's minus J 1 over omega C. Alright, now since we know the omega already, all we need to know is the C by comparing the right hand side and left hand side. So therefore, we just wanted to operate on the left hand side to make it to be in the real part, imaginary part. And we have done a problem similar to that already, that when we have this one here, what we need to do is we need to multiply on both the numerator and denominator complex conjugate of that denominator. So we're going to multiply by 0.1 minus J 0.2. And here in the numerator, we're going to do the same thing here. Now by doing that, what we have here is that we have a 0.1 squared plus 0.2 squared. And the numerator here is a 0.1 minus J 0.2. So 0.1 divided by the denominator and the negative J 0.2 divided by the denominator. And we work that out, and it can be easily shown that's equal to 2 minus J4. Now, this is the left-hand side. So by comparison, that clearly we can see R is simply just equal to 2 ohms, where 1 over omega C is equal to 4. So from there, C is equal to 1 over 4 omega, which is equal to 1 over 400 because omega equals 100. And that gives us 0.0025 farad. Now we can express that in more common terms to make it a millifarad. That will be 2.5 millifarad. So from this example, we see how the Y is working just as if any other complex number phasors. We just constantly need to remember that Y is the reciprocal of J. So this is the example how to operate Y